Hello.
Hi, how's it going?
Today, we will be explaining the concept of linked lists.
Spooky.
Now, they're not that difficult to do after you've learned it, but it does take a little bit of time to kind of visualize it. So, starting about in 10 seconds, there will be a visual representation of what a linked list does.
Yep, it's gonna help you maybe.
Beep!
Didn't work, Danny. What are we doing? There's no visual representation.
It will be there. 3, 2. Okay, so after that visual representation, let's show you what it actually looks like in practice. So there are two main things, and we're doing this in Java. It's a little bit different in C.
A little bit more.
There's a lot more.
It's like insanely more complicated is the correct way of saying that.
Yeah, whatever. Okay. So the idea is that you have two classes, one of nodes, which are chained together in a linked list.
Which you should have got from the diagram.
Right. So first of all, we need to obviously make the head.
Oops. It's been a while. So we go ahead and define it as null, since initially the linked list would be empty.
Alright, so now let's go to node. Let's edit node. So what kind of information should we do this time?
So obviously, for a linked list to work, each node has to point to the next node. So in order to do that, you do something a little tricky here, and you create a node inside of the node class.
Called next. That's insane.
Yep. So basically, this variable is going to store the next node in the list, and then in that node, it's going to store the next node, and so on and so forth. It's kind of like matrix going into the first node class, or the head.
Alright. So let's decide what we want to store in here.
I don't know, just an integer.
Store like name and age. Alright, I guess we can just do it into
Age
equal 0.
Okay. And then you want to get some accessor methods?
No.
No? Maybe change them to public then?
Yeah.
Okay.
I mean, you don't even have to do public.
Yeah, I do.
No, you don't.
I have to.
You do dot.
No, you have to do public to do that. If you're the private, you can't do dot.
No, if you don't have a definer. But anyways.
We're already fighting.
Whatever. Alright, so for the linked list, to traverse through the array, you obviously need a current node. So
Like a constructor.
yeah, we can do that first. You need your
I know.
parentheses. Right, so headers already know, but it is okay.
Let's take this away.
Yeah.
There, happy?
Yeah, it doesn't actually
Okay.
matter.
So we're gonna need a add node method. Oops. And to use that, we're gonna need an integer for the age of the node. What this has over here? It's hiding from me. So obviously, the first thing we need to do is we need to either add it to the head or to anywhere but the head, since the head is specifically named inside of this class. So go ahead and just check to make sure. If the head is empty, then we make head equal to a new node with our thing. But in order to do that, I need to go ahead and make a constructor over here. Alright. You gonna talk it all, Danny?
Nope. Make it current.
Make it current?
Yeah.
So we're gonna need a pointer node. Doesn't really matter for public or private right now.
Yeah. Basically, you just need that so that when you're traversing through the array, you have a reference point if you're gonna manipulate data. So generally, you set current equal to head because you want to start at the beginning of the linked list. And so here, what Jack is doing is that while current is not equal to null, you're basically adding the node to the end. And maybe later on you want it to be alphabetized, but for now we're going to keep it simple and just chain the nodes. So right there, you're traversing through. And then now, since current is at the very end, you want to set current.next equal to something new. So you're going to do current.next equal new node and then num. And it's simple as that.
Yeah, so basically what it does is, even though, so current is equal to the node that it's currently at, and so any changes done to current actually change the node inside the linked list. So when we set current.next equals new node, the node inside the linked list that's nested inside of all of the head and so forth, all of its nexts will actually be changed.
Because they each point to a specific data address, not necessarily like the physical data packet.
Mm-hmm. So obviously, if you wanted to make this a little bit more complicated, you could go in and make it alphabetically ordered, or numerically ordered in this case, and that takes some more statements inside of this area. But for now, we're just going to add it in the order that you are adding them in.
Yeah.
So.
Okay, so besides add, you also need, what do you want to do now? Do you want to do delete, or do you want to do...
We can do delete if you want.
Alright, sure. So let's do delete node. We need that.
Oops.
Alright, so similar thing here. If it's only, does this one need only head? No, you can do the entire thing. So you need that while statement that traverses. Yeah, you can set your current, you go ahead. And then you traverse again, but while current dot, instead of current dot next, oh yes, and, oh, do you want to do an if statement?
Do we need it?
I mean, if we're deleting, we gotta find which node we want to delete, right?
Yeah.
Which means that you can either put it in the while or you can put it in an if statement. Does that make sense?
Yeah.
Yeah. So while current dot next not equal to null and current dot is it age? Yeah. Not equal to num. Because if it does equal num, then it will stop. And then you will have the node that the age equals the age that you're looking for. So,
Okay.
what you have to do now is just a couple things. So, you're on the node that needs to be deleted.
Unless it is searched all the way through the array, not finding.
Right.
So, in which case, we need to check once again. Then we need to delete current.
Yep.
So, should we make a previous or should we loop again?
Oh, I see what you mean. Okay, so
I'm just gonna go ahead and do this. So there's two ways of approaching this issue. So right now, in order for us to delete the node, we need to make the node before current point to the node that current is currently pointing to.
Yeah.
If that makes sense. That should from the diagram. Basically, you can do that by either already having the previous saved inside your node, or you can search a second time with current too, which is what we're gonna do here just because I felt like it. I don't know.
Sure.
It's probably a little more complicated to do it this way.
Way to go.
You know. So we need another while.
All this does is show the importance of
Doubly. Linked list.
doubly linked lists.
Doesn't equal current.
Uh-huh. So that would traverse until the one before.
Oops, I don't need a zero there.
So
And I also don't need
basically,
parentheses.
once you have the once you have current 2 figured out, now you will point current 2 to current dot next. Right.
Okay, so basically, all of this wouldn't have been necessary if we had instead had a previous up here.
Right.
And the previous would basically make this a doubly linked list, which means you can traverse either forwards or backwards through it. And obviously, that's the main importance of it, especially if your add and remove had a bunch of other code in there, including trying to make it alphabetical or in numerical order, or if there's other data types inside your node. So this is just more of demonstrating that it can get overly complicated if you try and do this similar way.
You can do this. You can make it so that all the nodes are shifted up, or you can just skip the pointer and then set the current node equal to null. So there's a couple things you can do, but it just depends on what style you want to code. So if you want to make it work efficiently, then you need to start out more complicated. But that's just the nature of object-oriented programming.
Yep.
So add and delete are your main ones. We're obviously not going to go through sort because it works like every other sort instead of an array. But yeah, you guys know how to traverse it because it's just the same while current not equal next and then just system out the print line.
Yep.
But just make sure that to make the linked list back up in the main code is where you're going to have to declare the linked list as an object. So for instance, linked list like x equals
new list.
Okay, sure, equals new linked list. Right?
So obviously we don't have anything in our constructor that needs parameters. But if we were to create a first node, we'd have to do list dot add node and then for
6
instance,
or something.
6, yeah.
Or whatever you input. So just make sure you do that. And there, like Java does have its own linked list class, but this is what you would want to do if you want to make your own type of linked list.
Yeah, it can be a little more complicated, especially wrapping your head around it and actually coding it for the first time. But overall, it makes it so much easier in the long run because you have a lot more freedom with what you do.
Yeah, so that's pretty much all of it.
Yep. There's also different ways of organizing your linked list. For instance, there are things called stacks and queues. I think we might have mentioned them earlier.
Yeah.
Basically, a stack would mean when you do remove node, it removes the most recently added node. Similar to how if you think about like if you have a stack of blocks, you can't take off the bottom block without the rest falling. So you take off the top block, and you keep going down the stack of blocks in order to remove them from adding on the list. And then a queue works like waiting in line at, for instance, let's say the grocery store. The first person to enter the line is the first person to leave the line. So you'd always be removing from the head of your linked list rather than the tail, like with the stack.
And then there's another one called binary trees where instead of moving like next, or previous, it's left and right. And it basically starts with the center one and then it organizes it from there. So it has an inherently built-in sort because you go from left to right, and the way that you make it output what you want is through different types of traversals, not sorting the actual array like every time.
And obviously when Danny says inherently built-in sort, obviously you're going to be coding that built-in sort, but what your add node function will do is it will sort it in either alphabetical or numerical order to the right or the left, and then when you traverse it, it will be automatically sorted for you, which is really helpful if you're making, for instance, a database or something.
Right, and then the last thing would be a hash table, where a hash table is just a linked list of linked lists, basically.
Or an array of linked lists.
Right, and the way you sort it is you decide how to organize it by making up your own algorithm. So,
I didn't know this.
Right, so you can have that array. Yeah, you need to define the size.
Let's say 10.
Right, and then to sort which array area it goes into, you use something called a hashing algorithm, and that's just whatever you want it to be.
Yeah, you create your own hashing algorithm for this. So, actually, I'm going to put it right here. I'm going to put hash. So, basically, each element in this array is a new linked list. And in order to determine which linked list you're going to go into, you'd create a method that returns a number that is the element of the linked list.
Yep. And
that's all based on yourself, but it's just a way of organizing data, not necessarily a built-in data organization tool.
Yeah. So, that's pretty much everything.
Hope we helped you out.
Dynamic data structures are great.
They're pretty great. A little complicated at first, but very useful.
You'll get used to them.
Thanks for watching.
Goodbye.